Algebraic equations, solving by factorizing the difference between two squares. Do you still remember the difference of two squares? Look carefully at this definition. An expression of the form a squared minus b squared is called the difference between two squares. To factorize a difference between two squares, we use the identity a squared minus b squared is, and it forms two brackets, a plus b times a minus b, where a and b represent numbers or algebraic expressions. Let's check your understanding of the definition by looking at an example. 9x to the power of 4 minus 4y squared. We need to create an equivalent expression. We need to factorize. So we need two brackets with a negative and a positive, and we'll square root each perfect square. And that will be equal to 3x squared minus 2y times 3x squared plus 2y. So to summarize, p minus q, where p and q are perfect squares, then you've got two brackets, and in the one bracket you'll have the difference of the square root of the two numbers, and the second bracket the sum of the square roots of the two numbers. Let's do an example. Write this in your book and see if you can do the answers. X squared is 4. Well, you can square root both sides and then x is a positive or a negative 2. Or you make the expression equal to 0. You'll notice that there's the difference between two squares. You'll factorize, and then x minus 2 is 0 and x plus 2 is 0. Therefore, x must be 2 and x must be negative 2. Remember to check your answer. Let's do another example. What about 64a squared is 25? Use the zero product property. The expression must be equal to 0, so subtract 25 from each side. Then factorize the difference of two squares. 8a minus 5 will be 0 and 8a plus 5 will be 0. Therefore, a will be 5/8 and a can be negative 5/8.